Continuing our discussion about polynomials, let's explore a little bit about powers. There's two kinds of power polynomials. They fall into the category of even polynomials, or they fall into the category of odd polynomials. I'll start with even polynomials. The nice thing about even polynomials, fourth, sixth, eighth powers, etc., is they act just like quadratics. We do a lot of studying of quadratics. Fourth powers, sixth powers, etc. act just like quadratics do, and they end up having either an absolute maximum or an absolute minimum at the vertex. The other half of our polynomial powers is the odds. Now the odd powers are a little different. The domain changes. We still have negative infinity to positive infinity, so all reals. So that's the same as the evens, but the range is very different because the range is now also all real numbers, negative infinity to positive infinity. The other big change with odd powers is you have possible relative maximums or minimums. Sometimes we refer to these as turning points, not the same as an even. Even has an absolute maximum and an absolute minimum depending on which way it points. The other thing we like to do with our powers is we'll do what's called the leading coefficient test. The leading coefficient test is a way for me to know what this looks like before I graph it. If you think back to when we studied quadratics, when a was positive, this quadratic pointed up. Even powers act the same. They are up on both ends. If it's negative, this quadratic points down. It is down on both ends. All even powers act that way. If I move over here to the odd powers, when a is positive, odd powers are down on the left and up on the right. So something like this green here, down on the left, but going up on the right. If that leading coefficient would be negative, it's the other way around. It's going up on the left and down on the right. For all functions, whether they are even or odd powers, all functions have at most n real zeros. So the largest power that you see is the maximum number of roots that that function is going to have. Going with that, the graph of these functions has at most n minus 1 relative extrema. So let me give you an example. If I have something that has a largest power of 4, I know that it has at most 4 roots. I also know that it might change direction. It might have a turning point 3 times. It's always 1 less. So a quadratic has at most 1 turning point. A fifth power would have at most 4 turning points, even though it has 5 real roots. And this is universal for all the powers. They fall into the category of either being an even or an odd power, and they have these characteristics. Now let's take a look at some examples of these functions. We'll start with our TI graphing calculator. I've put in a couple of functions. Let's start with the first function, y1. Going to highlight the equal sign and turn it on. So now you'll see that the equal sign is darkened. So when I hit graph, I'll be able to see my function. You'll notice that I'm dealing with an x cubed function. So I know that this is an odd power, and looking at the number in front of x cubed, it's positive. So I'm expecting my function to be down, then up, and at most 3 zeros, 2 turning points. So if I graph this, you can see it came up, so it was down, it came up. There's a turning point just off of my screen. It decreased again. I had a turning point down here, and it turned one more time, and then it was going up or increasing, so it was down on the left, up on the right. what we expected out of this particular cubic. I'm going to go back into my y equals. I'm going to turn off my cubic, and I'm going to go down here and I'm going to turn on my fourth power. Now you'll notice that my fourth power is a negative fourth power. So negative means it should point down on the left and down on the right. It's going to cross the x-axis at most 4 times, and I should expect no more than 3 turning points. So when I hit my graph button for this fourth power, I should expect it to come up over here on the left. Then it went down. Then it went up again. And then it went down. I know these are hard to see, but it's got a turning point right in here, down here, and up high again. But notice that it's down on both the left and the right, characteristic of an even polynomial. Now let's take a look at some similar things on the Desmos graphing calculator. So here's my Desmos graphing calculator. Again, I have a cubic ready to go, and notice it's negative. So I would expect it to be up on the left, down on the right, 3 solutions, and 2 turning points. So we're up on the left, down on the right. We've got 1, 2, 3 solutions, and we've got 1, 2 turning points, just like we expected. If I go to the fourth power, notice it was a positive, so it was up and up. It's got 1, 2, 3, 4 solutions, and it's got 1, 2, 3 turning points, just like we would expect. The last one I've got here on Desmos is a cubic. So I would expect 3 solutions, 2 turning points, and since the number in front is a positive 1, should be down on the left, up on the right. So I turn this on and notice it's down on the left. So it is increasing until it hits this relative maximum, decreasing until it hits this relative minimum, and then increasing again. So it's up on the right, down on the left. It's got 1, 2, 3 solutions, just like we expected. It's got 1, 2 turning points, also exactly what we expected to have in our odd power.